Yeah. All right. Day 2. Rational graphs.
Is it gonna be way harder than yesterday?
Will you hit those lights, Selene, please? Thank you, ma'am. All right. Yesterday I showed you several different graphs, what things could look like. One of them kind of looked like this. One of them looked like Nike swoops, maybe. Some of them may look.
Is that for today?
Yes, these are all today. There's not just a general form that they may be. Some of them may look like this. This. Lots of different shapes we can have. Some of them may do this. Sometimes the asymptotes will bound certain parts of the graph and not other parts. So you see what I'm saying? Sometimes 2 points aren't going to be enough to pick up the pattern. Sometimes you might have to pick up some more points to pick up the pattern. There's one that does kind of like this. This one. Okay. They're just kind of all different shapes, so you really have to follow along. That's why I made the step sheet for you with how we look at it. So if you look at the step sheet, under step 3, there's 3 different scenarios. There's an A, a B, and a C. I'm going to try to work through each of the 3 scenarios with you to show you how they differ, and then I'll set you loose. So y'all ready?
You gonna get a step sheet like yesterday?
We're still on the same one. Y'all ready? All right, let's look at this one. Does x have an exponent in the top or bottom of the fraction?
Yes.
Yes. So I'm in the right rectangle. Okay, which has a lot of steps, right? Oh, it has a lot of steps. Just be glad you don't have to memorize them.
Where are you going?
I'm in the far right rectangle because, yes, there's an exponent in the fraction. Do you see, Tanner? Do you see?
Yeah.
Do you see? All right. X-intercepts is step 1. X-intercepts are places where the graph crosses the x-axis. In this case, it says set the numerator, I have in parentheses the top, in case you get confused, equal to 0 and solve for x. Is that ever going to happen? Can 6 ever be 0? No. There are no x-intercepts. Anybody confused?
Nah.
Step 2. Step 2 asks me to find the vertical asymptotes. To do that, you set the bottom equal to 0 and solve. Okay. X squared plus 1 equals 0. So x squared equals what? -1. So x equals plus or minus. What's the square root of -1? I. Am I graphing in an imaginary plane? No. I'm graphing real numbers. Therefore, this function has no vertical asymptotes. That's fine, but it's still, we're graphing on a real number plane, so no imaginaries. All right, step 3. I'm going to put it up here. Horizontal asymptotes. Now here's where you have to find which scenario best describes your graph. There are three. You're looking at the degree of the numerator and the degree of the denominator. What's the degree of the numerator? No. What's the I didn't fry him. What's the degree of the top? What's the biggest exponent hooked on x? Zero. Yes? It doesn't have an x, but anything to the 0 power is 1. So I could multiply 6 by 1 so it really has a 0 degree. Yes? Remember that chart we did when we did polynomials? We classify the polynomials based on their degree. If it's a constant, it's got a degree of 0. What's the degree of the denominator? 2. So look at my three scenarios. Is the degree of the top greater than, less than, or equal to the degree of the bottom? Some of you are saying it, but you're very hesitant and you're saying it. Less than. Does everybody agree that 0 is less than 2? What scenario is that? A, B, or C? On your sheet.
A.
Scenario A. Read it with me. If the degree of the numerator is less than the degree of the denominator, then y equals 0 is your horizontal asymptote. Does that make sense? I finally have something to graph. Now, here's where your calculator is going to really come in handy. My last step tells me to make a t-chart. I don't have any vertical asymptotes to pick either side of. So what I'm probably going to have to do is graph it on my calculator and get a general feel of what it looks like to know which points to pick. So if you go into your calculator, Quackalator. I've got 6 divided by, I'm going to put this in parentheses, x squared plus 1. Ooh.
Well, I put 6 in parentheses.
Oh, that's really cool.
Really cool. You don't have
And
to.
then we could say where the value of...
What values do you think are some good values to pick up the pattern? 0, -1, and 1, maybe.
0 equals 7.
Right there in the middle, enough to pick up the high point here, and 1 on either side, maybe. So I'm gonna say -1, 0, and 1. Does everybody see why I chose those numbers?
-1, 0, 1.
Uh-huh.
Yeah, why you chose them?
Oh, I looked at the picture and I kind of looked to see what I would need to pick out to get a good representation of this graph. So we figured if I chose -1, 0, and 1, I could get a good enough picture. I could get enough of the pattern that I could sketch a graph. Put them on here. And now I'm just going to kind of sketch what I know. I know this is an asymptote. It's going to hug here. An asymptote, it's going to hug here. Does that make sense to everybody?
Yeah.
What's the domain? Good job. -infinity to +infinity. What's the range? Yeah, close. 0 to 6. The 6 has a bracket because it includes 6. It goes up to 6 and then stops. Yes or
It's
no?
down to up.
Yep. Always.
That's right.
Yep.
Oh, rain down
Yes, no, maybe so. Ready for another one?
Cool dudes, cool dudes.
Let's do one that is, this one was bottom heavy. Let's do one that's equal. Let's do y equals 2x squared, x squared minus 9. All right. I'm still in that same box, yes?
Oh, look, you know y equals 2x yeah.
First step, X-Intercepts and Graphs. If I set the top, 2x squared equals 0. If you solve that for x, what do you get? Oh my goodness.
X squared equals 0.
If you divide 0 by 2, you get 0. If you take the square root of 0, you get 0.
Y'all can do like
So we can go and take the asymptote.
All right, nope, that's an x-intercept. Right there at 0. Step 2. Find the vertical asymptotes.
set the bottom to 0.
Set the bottom to 0. X squared minus 9 equals 0. Plus 9. What does x equal?
3.
What? Plus or minus 3.
Wow.
Which is going to make a big difference because now I have a vertical asymptote at negative 3 and one at positive 3.
What in the world?
What?
Heck no.
Looking at step 3. Is the degree of the numerator greater than, less than, or equal to the degree of the denominator? Equal to, that is scenario B. If they are equal, then the asymptote is the ratio of the leading coefficients, just like the ones we did yesterday. So what is my horizontal asymptote? 2.
How?
If they're equal, then it's the ratio of the leading coefficients.
Never mind.
So that's
2 divided
2 divided by 1.
Getting a little messy here, huh?
by
So we gotta have to put that 2.
T-chart. Now this time I do have some vertical asymptotes. So as I look at these vertical asymptotes, I think that I am going to pick -5, -4, -2, -1, 1 and 2. I told y'all. 3 and 4.
Wouldn't it be 4 and 5?
Yep, it would. You're correct, Tanner. She gets super free.
It's a brick. Ouch.
So again, I'm very grateful to have a graphing calculator that I can plug this in and just go to my table and pull those
Oh,
values.
that's really cool.
So someone who has this typed in already, give me some values here.
All right.
What is -5?
is 3.125.
Okay,
-4 is 4.5714.
that's good.
-2 is -1.6.
Okay,
-1 is -0.25.
okay,
1 is -0.25.
okay,
2 is -1.6.
okay,
And 5 is 3.
4.
4, sorry. 4 is 4.5714.
okay.
And then 5 is 3.125.
Nice. Everybody get that when you plug it in your calculator? Yeah. You look at the degree, you look at the biggest exponents top and bottom, and you decide if it's the top is greater than, less than, or equal to the bottom, and then you follow the scenario under step 3 on your paper. So since these were equal, we went with scenario B. Yes. I'm going to start plotting points, because this is going to take me a little bit. You start plotting them as well. -5, a little above 3. -4, 4.5. -2. -1.6. -1. -1/4. 1, -1/4. 2, -1.5. Somewhere in there. 4, 4.5. And 5. 3.1. I'm going to connect. I know what it should look like based on my calculator. What do y'all think? Looks pretty cool, right?
No.
You felt like frying me. You got me, Shamik. I tell you what. I don't know if I'll recover from that. Let me hit record. What's the domain here?
So for the very bottom.
Left to right. Domain is left to right.
Okay. For the left.
-infinity to -3. Uh-huh. Yes. Good job, guys. Give yourself a pat on the back. That was hard. Yes. Because there's 2 vertical asymptotes.
You knew that, right? You knew that?
All right, before you blurt this one out, think very carefully and look carefully at the graph.
So then it's going to be.
Range of this one is -infinity.
So, no.
To what, Shamik? Say it. Y0. Look, it stops there. I got a space of graph with no graph. I got a space on the graph with no picture of the graph. So it's 0 with a bracket. Where does it pick back up? 2 with a parenthesis up to infinity. I had to leave this whole space out right here because there's no graph anywhere in that area. Does that make sense? Yeah. Yes, sir.
For the domain, can you put like all reals except for -3, except for -3?
Well, we like it to be in, that's not wrong. It's just not interval notation. I try to get y'all used to interval notation because in pre-cal, that's all you can use is interval notation. Yes, no, maybe so?
Yeah.
Homework?
It's not as hard as last.
One more scenario. Yes, ma'am. X squared plus 3x minus 4 over x minus 2. Don't.
Oh, this ain't got no. Oh, I was about to say it ain't got no exponent, but it do.
It does. X-intercepts. Set the top equal to 0.
X to the second plus 3.
Uh-oh. I have a quadratic equal to 0.
I love quadratics.
I told y'all. It is funny.
Opposite B plus or minus.
This one factors. This one factors. This one factors. You can. I'm gonna use 4 and -1. right?
Get off of the screen now.
Is that a plus 4?
It's just a regular just plus 4?
No, it's x plus 4. It's just off of the board.
Oh.
So x equals -4 and x equals 1. Vertical asymptotes. Okay.
Yeah, we need to roll these.
Vertical asymptotes. Set the bottom equal to 0 and solve. X equals what?
2.
Y'all so smart.
I like it, I like it.
Horizontal asymptotes. Which scenario? Greater than, less than, or equal to? Greater than. The degree of the numerator is greater than the degree of the denominator, so it's top heavy. No horizontal asymptote.
Why isn't it plus 1? Never mind.
Now make a T-chart. Yes. Yeah. I have no earthly idea what this graph is going to look like. I have no earthly idea which points to pick. Something crazy's going on if I've got all of this over here crossing twice. I might have to pick more than just 2 points on either side of the asymptote. So maybe I should graph it and see what it looks like.
It says that there's no such
You talking about on the calculator?
The quackalator.
It says that there's no such thing.
Computer lady.
Oh, I did it wrong.
Computer lady.
Let's see.
Now, boy, I'm good. Am I right there?
Yeah, make sure your numerator and your denominator are in parentheses. X
I like this.
squared plus 3
Oh, you put that
x minus 4 divided by
plus 3x
x minus 2.
minus 4. Close parentheses.
Oh, oh!
Divided by.
Do what?
So 2 is going to be the y.
Oh, look what y'all found out. I need to go up some more, right? See why we spent all that time playing with our calculators and the windows and everything? What you, Rosa, Anthony, what y'all go up to? What'd you say? 20?
It goes down to -23 and starts back up at 67.
What?
Yeah.
Cool.
I just kind of want to see where I need to go, so I'm
I
thinking...
don't look like this. It's ugly. Oh, let me eat like that. What is this?
Does it not look like
Let me
mine?
see. Let me see that.
You did. When you're looking at which points to pick, which x's to choose, I want to make sure that I choose enough. I know how it hugs, but I want to make sure I choose enough in this vicinity that are going to show me that scoop there, if that makes sense. And same over here. This one's a little bit easier. Maybe if I pick like the high point here, so maybe if I pick around -1 or 0. It's 2. So, but what did you plug in for your x's is what I'm saying. 0. 0, 2 is a point on there. All right, so you plugged in 0 for this one, and you got 2. So I can kind of pick up that pattern there and know that it's going to go like this.
And then 3, I got 14.
2. All right, 3, you got 14. Way up here somewhere. What about 4?
4, I got 12.
12. I'm going to need to pick enough until it starts going back up again. Does that make sense? What'd you get for 5?
5, I got 12 again.
12. And 6?
6, I got 12.5.
So it starts going up again at 6. 3, 4, 5, 6. Goes up a smidge. Right? No. That's 5. 4 and 5 are the same.
Yes.
6 starts going up just a smidge again. So I'm kind of doing this number. Hugging that asymptote there. You can't really, I'm trying to write kind of crooked here. Does that make sense? Do you see how we picked the points that we picked? That's what I really want you to see. We're going to have to kind of guesstimate on the range a little bit. The domain is easy. What's the domain? Negative infinity to 2 unioned with 2 to infinity. Range is a little trickier. Because remember, anytime there's no graph, we have to leave all that out. That's not part of the range. There's no graph there.
That's part of the graph though.
So,
That is part of the graph
not part of the,
though. It goes,
yours is graphing the asymptote on it. All right, so what's my range? Negative infinity. I would take it up to 2. I would do a bracket. Union. Would you, about 12. Somewhere, you just estimate it. Some of you might have something a little different, and that's
We
fine.
might have 60 back then.
No, if you have something like that, it's off. You could actually go in and calculate the minimum there, like we talked about calculating
Yeah, I
on our
did.
calculators. And it's probably like 12 point,
it was 12.5.
yeah,
6.
okay.
Those are like 13.
All right, questions, comments, concerns? What do we think about graphing?